Hello there, and welcome to Earth's history, where the past stretches deeper than memory, where time erases evidence as thoroughly as wind erases footprints in sand, and where the possibility of lost chapters haunts the edges of what we think we know. Tonight, we're asking a question that sounds like science fiction, but touches on genuine scientific inquiry. A question that challenges our assumptions about humanity's place in Earth's long story. What if we're not the first? What if, before our cities rose, before our civilizations emerged, before even our species walked the Earth, there were others, other intelligent species, other technological civilizations, other builders and thinkers who rose, flourished, and vanished so completely that almost nothing remains? If you've ever looked at the immensity of geological time, at the 4.5 billion years of Earth's history, and wondered how much could be hidden in those ancient epochs, you're asking the right question. If you've ever considered how little of the geological record actually preserves, how much has been destroyed by subduction and erosion and metamorphism, you're beginning to understand why this question isn't as absurd as it first sounds. And if you've ever felt that peculiar vertigo when confronting deep time, that sense that we might be seeing only the tiniest fraction of what has actually happened, you're ready for this journey. Wherever you are right now, I hope you're comfortable, settled, ready to explore one of the most unsettling and fascinating questions we can ask about our planet. Maybe you're lying in bed as darkness gathers. Maybe you're sitting quietly as your mind wanders through possibility. Maybe you're in that contemplative space where certainty gives way to wonder, where what we know meets what we can't know, where the boundaries of the possible expand into uncomfortable territory. If this exploration into deep uncertainty brings you a strange kind of peace, if it helps you see human civilization as contingent rather than inevitable, as one experiment among potentially many, I'd be grateful if you'd like the video, subscribe to the channel, or share it with someone else who finds comfort in confronting cosmic scale questions. So settle in, let your breathing slow, like the patient deposition of sediment. Let your thoughts drift through millions of years, like continents across a restless planet. And let's begin. Because the question, are we the first civilization on Earth, has a surprising amount of legitimate scientific thinking behind it, and the answer might not be as obvious as you think. Part 1. The Silurian Hypothesis. In 2018, two respected scientists, Gavin Schmidt, director of NASA's Goddard Institute for Space Study, and Adam Frank, an astrophysicist at the University of Rochester, published a paper with a deliberately provocative title, The Silurian Hypothesis. The name references a Doctor Who episode featuring intelligent reptiles that evolved on Earth before humans, but the science is serious. The paper asks, if an industrial civilization had existed on Earth millions of years before humans, would we be able to detect it in the geological record? Their answer, after careful analysis, is unsettling. Probably not, or at least not easily. The geological record is far less complete than most people realize. The older you go, the less rock survives. Plate tectonics recycles oceanic crust every 200 million years or so through subduction. Continental rocks are subject to erosion, burial, metamorphism, melting. The surface of the Earth is constantly being destroyed and remade. Consider this: all of human civilization, from the first cities in Mesopotamia to the present day, has occurred within the last 10,000 years. That's 0.002% of Earth's 4.5 billion year history. It's a blink, an instant, a moment so brief it barely registers on geological timescale. If our civilization ended tomorrow, if humanity went extinct and millions of years passed, what would remain for future geologists to find? Not much, it turns out. Our cities would erode, our plastics would break down, though slowly. Our concrete would crumble, our steel would rust. Within a few million years, almost everything we've built would be gone, ground to dust, buried beneath sediments, recycled by the restless planet. What would remain would be subtle. A thin layer of unusual materials in sedimentary rock perhaps, elevated concentrations of certain metals, changes in carbon isotope ratios reflecting the burning of fossil fuels, elevated background radiation from nuclear tests. But nothing obvious, nothing screaming, civilization was here. The paper's thought experiment goes further. What if an industrial civilization existed not 10,000 years ago, but 50 million years ago? 100 million? 300 million. The further back you go, the less likely any trace would survive. The rocks from those periods have been subjected to more time, more weathering, more geological processing. The chances of finding direct evidence, building, tools, bones of the civilization's members approach zero. This doesn't mean ancient civilizations existed. It means we should be humble about what we can detect, about what leaves traces, about what survives the vast destructive power of geological time. The absence of evidence becomes less meaningful when you understand how little evidence would remain even if something had existed. Schmidt and Frank's paper was partly about exoplanet research. If we're looking for signs of past civilizations on other worlds, what should we look for? But it sparked broader discussion. Could there have been previous civilizations on Earth? Not human civilizations, obviously, but other species, other forms of intelligence, other experiments in technology and culture that rose and fell long before our ancestors climbed down from the tree. The standard scientific answer is almost certainly not. But that almost is important. It's not impossible, just extraordinarily unlikely. And exploring why it's unlikely, what evidence we'd expect to find, what traces might survive, teaches us something profound about time, about preservation, about the fragility of everything we build. Part 2, the vastness of deep time. To understand why this question is even worth asking, we need to confront the immensity of Earth's history. We need to really internalize what 4.5 billion years mean, which is difficult because the human brain didn't evolve to grasp such timescales. Let's try an analogy. If Earth's entire history were compressed into a single 24-hour day, here's how it would unfold. Midnight, 4.5 billion years ago. Earth forms from the accretion disk around the young sun. AM, 4 billion years ago. The late heavy bombardment ends. Earth stops being pummeled by massive impacts. The surface cools enough for oceans to persist. AM, 3.8 billion years ago. The first life appears. Simple, single-celled organism. 30 PM, 2.4 billion years ago. The Great Oxygenation Event. Cyanobacteria fill the atmosphere with oxygen. 30 PM, 600 million years ago. Complex multicellular life diversifies in the Ediacaran period. 9 PM, 541 million years ago. The Cambrian explosion. Animals with hard shells and skeletons appear. 10:45 PM, 250 million years ago. The Permian-Triassic extinction, the Great Dying, wipes out 96% of marine species. 11:30 PM, 65 million years ago. The asteroid that killed the dinosaurs strikes Earth. 58:43 PM, 2 million years ago. The genus Homo appears. 59:56 PM, 10,000 years ago. Human civilization begins. Agriculture, cities, writing, everything we consider history happens in the last 4 seconds of the day. This perspective is crucial. Complex life, animals with brains, have existed for roughly the last 3 hours of this 24-hour day. Mammals have been significant for only the last hour. Humans have been around for less than 2 minutes. Civilization for 4 seconds. That means there are approximately 3 billion years of Earth's history where life existed but was too simple for anything we'd recognize as civilization. Just bacteria and archaea. Then, eventually algae and simple multicellular organisms. But for the last billion years or so, and especially for the last 500 million years, there have been complex organisms with nervous systems, organisms capable of movement and sensing their environment. Could any of these have developed intelligence? Could any have created technology, built civilizations, left traces we haven't found or haven't recognized? Part 3. What we mean by civilization. Before we go further, we need to define terms. What do we mean by civilization? For this discussion, let's use a broad definition. A civilization is a species or group of species that develops technology beyond simple tool use, that modifies its environment on large scale, that creates structures and artifacts that persist beyond individual lifespan, that accumulates knowledge and passes it to future generations. By this definition, humans are obviously civilized. We build cities, use complex technology, alter landscapes, create art and writing and mathematics. We've developed industrial civilization specifically, which involves large-scale energy use, manufacturing, transportation networks, the transformation of raw materials into finished goods. But humans aren't the only tool users on Earth. Crows fashion hooks from wire to retrieve food. Sea otters use rocks to crack open shells. Chimpanzees use sticks to fish for termites, use stones to crack nuts, even use spears to hunt. These are simple tools, yes, but they demonstrate that tool use itself isn't uniquely human. What about other signs of intelligence? Elephants mourn their dead, returning to the bones of deceased family members, touching them with their trunk. Whales and dolphins have complex communication systems, possibly even names for individuals. Octopuses solve puzzles, escape from enclosures, seem to play and show curiosity. Corvids, crows, ravens, jays, demonstrate reasoning, planning, even theory of mind, understanding that others have thoughts and intention. Intelligence, in the sense of problem-solving ability, learning, adapting to novel situations, is actually fairly common in the animal kingdom. What's rare, what seems unique to humans so far, is the particular combination of abilities that led to civilization. Abstract reasoning, complex language, fine motor control enabling precise manipulation, and crucially, the tendency to build on previous knowledge, to create culture that accumulates over generations. But so far is the key phrase. We've only been looking at Earth's current biosphere. What about the past? For hundreds of millions of years, complex animals have existed. For hundreds of millions of years, brains have been processing information. Organisms have been adapting. Evolution has been experimenting with different forms of intelligence. Is it possible that at some point, some species developed further than we know? That some lineage of dinosaurs perhaps, or some group of mammals, or even some organism we've never imagined, developed intelligence, developed technology, built something resembling civilization before vanishing? Part 4. The dinosaur question. Let's address the most obvious candidate, dinosaurs. They ruled the Earth for 165 million years, from about 230 to 65 million years ago. That's an enormous span of time, more than 30 times longer than mammals have been dominant. During that time, dinosaurs diversified into thousands of species, occupied every terrestrial niche, evolved extraordinary variety in size, shape, and behavior. Some dinosaurs had large brains relative to their body size. Troodon, a small theropod from the late Cretaceous, had one of the highest brain-to-body ratios of any dinosaur, with large eyes suggesting good vision, grasping hands with opposable digits, and a body plan suggesting it might have been quite intelligent by dinosaur standards. Could Troodon, or something like it, have developed further? Could there have been an intelligent dinosaur species that used tools, built structures, created technology? This is the premise of countless science fiction stories. But what does the evidence say? The answer, based on current paleontological evidence, is almost certainly no. We have extensive dinosaur fossils from the Mesozoic era. We know their anatomy in great detail. We can see their teeth and infer their diet. We can examine their bones and understand their growth pattern. We can find their footprint, their nests, their eggs, sometimes even preservation of skin texture and feather structure. If any dinosaur species had developed civilization, even primitive technology, we'd expect to find evidence. Tools made of stone or bone, which preserve well. Modified environments, clearings, or structures that would leave traces in the rock record. Changes in other species' populations due to hunting or domestication. Unusual accumulations of certain materials, suggesting mining or quarrying. We find none of this. Dinosaur fossils show animals that were, by all evidence, just animal, sophisticated animal, successful animal, some quite intelligent, but not technological, not civilized in the way we're defining it. But here's where it gets interesting. What if they had existed, not during the age of dinosaurs we know about, but earlier, or in a gap in the fossil record, or in a region where preservation is poor? The fossil record is incomplete, very incomplete. Paleontologists estimate that we've discovered perhaps 1% of all species that ever existed, maybe less. Fossilization requires specific conditions, rapid burial, protection from scavengers, the right chemical environment for mineralization. Most organisms die and decay completely, leaving nothing behind. Moreover, the older the rock, the fewer survive. The fossil record for the Triassic is sparser than for the Cretaceous. The Permian, sparser still. The further back you go, the more has been destroyed, eroded away, subducted, metamorphosed beyond recognition. Could there have been a dinosaur civilization, or a pre-dinosaur reptile civilization, that existed briefly? In geological terms, briefly might mean thousands or even millions of years, and left so little trace that we haven't found it. Could the evidence exist in rocks that have been destroyed, or in regions we haven't explored? It's not impossible, just extraordinarily unlikely. The burden of proof for extraordinary claims is high, and right now, we have no compelling evidence for such civilization, but the fact that we can't completely rule it out is itself noteworthy. Part 5. The problem of preservation. Let's think more carefully about what might survive from a hypothetical ancient civilization. Suppose, for the sake of argument, that 100 million years ago, during the mid-Cretaceous, an intelligent species arose. They existed for, let's say, 1 million years, a reasonable time span for a successful species. During that time, they developed technology roughly equivalent to human Bronze Age or Iron Age civilization. They built cities, mined metals, used fire, created tools, perhaps even developed writing and mathematics. Then they went extinct. Climate change, disease, war, resource depletion, asteroid impact, the cause doesn't matter. They disappeared, and evolution continued without them, eventually leading through many intermediate forms to us. What would remain? Direct artifacts, tools, buildings, manufactured objects. These are what we think of first, but they're also the least likely to survive. Stone tools are durable, and we find them from early humans, going back millions of years. But even stone erodes, gets buried under sediments, gets destroyed by geological processes. A stone tool from 100 million years ago would be extraordinarily unlikely to survive in recognizable form. Metal tools are even worse. Metals oxidize, corrode, break down, iron rusts, bronze corrodes. Even in the relatively short time since ancient civilizations like Rome or Egypt, metal artifacts survive only when protected by unusual conditions. Dry desert climate, sealed tombs, shipwrecks in oxygen-poor environments. Over millions of years, virtually all metal artifacts would disappear completely. Buildings and structures face similar problems. Erosion is relentless. Mountains erode to hills, hills to plain. Given enough time, any surface structures would be weathered away within millions of years, less if they're in tectonically active regions. Even massive structures like pyramids, given tens of millions of years, would erode to unrecognizable lumps, then to nothing. Underground structures might last longer, but they'd be filled with sediment, compressed by overlying rock, altered by groundwater. After 100 million years, even deep mines or underground cities would be difficult to distinguish from natural geological features. Fossil remains. This is more promising. We have fossils going back billions of years. Surely the civilization's members themselves would fossilize, and we'd recognize modified skeletons, worn teeth from cooked food, bone modifications from tool use, unusual population distribution. But here's the problem. Fossilization is rare, very rare. Most organisms decay completely. To fossilize, you need to die in the right place, usually water or rapidly accumulating sediment. Be buried quickly, be protected from scavengers and bacteria, and have the right chemistry for mineralization. Then, after fossilizing, the fossil needs to survive millions of years of geological processes and eventually be exposed at the surface where we might find it. The vast majority of species that ever existed left no fossils. We know they existed from evolutionary inference, from the pattern of relationships among species that did fossilize, but the species themselves are gone without trace. Civilization would have a population concentrated in specific areas. If those areas are now subduction zones, or under kilometers of sediment, or have been eroded away, or have been metamorphosed, we'd have no access to whatever fossils might exist. Geochemical signatures. This is where the Silurian hypothesis paper focused, and it's perhaps the most plausible trace that might survive. An industrial civilization would alter the chemistry of the environment in detectable ways. Burning fossil fuels releases carbon dioxide with a specific isotopic signature, depleted in carbon-13, relative to other carbon sources. This would show up in sediments as a carbon isotope excursion, a sudden shift in the ratio of carbon-12 to carbon-13. Mining and smelting metals would create unusual concentrations of certain elements in sediments near the civilization. Lead, copper, zinc, rare earth elements, all would show elevated levels in specific layers. Manufacturing plastics and other synthetic materials would leave traces of long-chain hydrocarbons that don't occur naturally. Nuclear technology, if developed, would leave radioactive isotopes, particularly long-lived ones like plutonium-239, that would remain detectable for millions of years. Large-scale agriculture would change erosion pattern, increasing sediment delivery to ocean, altering pollen distributions in sediment. These signatures are subtle, but potentially detectable. And here's the key point. We do find unusual geochemical anomalies in the geological record. Sudden shifts in isotope ratios, elevated metal concentration, extinction event, changes in erosion rate. We usually attribute these to natural causes, volcanism, asteroid impacts, climate shifts, but could some of them be traces of ancient civilizations? Almost certainly not. We have good natural explanations for the anomalies we found, but the point is that this is the kind of evidence we should look for, and it's the kind that might actually survive time. Part 6. Known anomalies in the geological record. Let's examine some actual mysteries in Earth's geological history, anomalies that have puzzled scientists, and ask whether any of them could possibly be explained by ancient civilization. Spoiler, the answer is almost always no, but the exercise is instructive. The Great Oxygenation Event. 2.4 billion years ago, Earth's atmosphere suddenly filled with oxygen, transforming the planet. This was caused by cyanobacteria evolving oxygenic photosynthesis. But it happened suddenly, geologically speaking, and had enormous consequences. Could it have been artificial? The result of some ancient civilization terraforming the planet? No, we have excellent evidence for the natural explanation. We can trace the evolution of photosynthesis in the genetic record. We find stromatolites, layered structures built by cyanobacteria, going back billions of years. The timing makes sense with evolutionary models. And 2.4 billion years ago, life was entirely single-celled. Nothing remotely resembling complex organisms existed, let alone civilizations. The Cambrian explosion, 541 million years ago. Complex animals with hard shells and skeletons suddenly appeared in the fossil record, diversifying rapidly. This has been called sudden because it happened over only 10 to 20 million years. Fast by geological standards, but still an enormous amount of time. Could it have been triggered by genetic engineering, by an ancient civilization? Could someone have seeded Earth with complex life? Again, no. We have increasingly good understanding of the Cambrian explosion's causes, rising oxygen levels, the evolution of predation creating an evolutionary arms race, the development of Hox genes allowing more complex body plan. The genetic relationships among Cambrian animals make sense in the context of evolution from Ediacaran ancestors. There's no need for outside intervention, no evidence suggesting it. Mass extinction. Earth has experienced 5 major mass extinctions and many smaller ones. Could any have been caused by ancient civilizations destroying themselves through war, pollution, or resource depletion? The mass extinctions we know about have clear natural causes. The Permian-Triassic extinction, 252 million years ago, was caused by massive volcanism in Siberia, releasing enormous amounts of greenhouse gases. The Cretaceous-Paleogene extinction, 65 million years ago, was caused by an asteroid impact combined with volcanism in India. The others have various causes: climate change, sea level changes, ocean anoxia, but all have natural explanation. Could there have been other extinctions caused by civilization that aren't in the Big Five? Perhaps smaller extinction events that we attribute to natural causes were actually anthropogenic, or rather, sophontogenic, caused by intelligent beings? It's theoretically possible, but unsupported by evidence. The extinction patterns we see match natural explanation. Species that go extinct in mass extinctions show patterns consistent with environmental stress, not with being hunted or otherwise directly impacted by another intelligent species. The Younger Dryas impact hypothesis. About 12,900 years ago, Earth suddenly cooled, interrupting the warming trend at the end of the last ice age. Some researchers have proposed this was caused by a comet or asteroid impact. Others dispute, arguing for natural climate variability. Could this have been a nuclear war by a previous human civilization? Could ancient astronauts have bombarded Earth? No credible evidence supports the Younger Dryas cooling can be explained by natural causes, probably a disruption in ocean circulation caused by meltwater from retreating glaciers. While the impact hypothesis is debated, even if an impact occurred, there's no reason to invoke anything other than a natural cosmic impact. And 12,900 years ago is well within the archaeological record for humans. We know what humans were doing. Then, hunting, gathering, beginning to experiment with agriculture, and there's no evidence of advanced civilization. The Mohenjo-Daro nuclear war claim. Some fringe theorists point to the ancient city of Mohenjo-Daro in the Indus Valley, claiming that vitrified stones and skeletons showing high radiation levels prove it was destroyed by nuclear weapons in antiquity. This is completely false. The stones aren't vitrified. The skeletons don't show unusual radiation. The city was abandoned due to climate change and river shifts, possibly combined with disease or invasion. This is a good example of how misinterpretation and sensationalism can create false mysteries. Uparts, out-of-place artifacts. Various objects have been claimed to be too advanced for their time. The Baghdad battery, actually probably for storing scrolls. The Antikythera mechanism, a genuine ancient Greek astronomical computer, but not out of place. The ancient Greeks were sophisticated. Ancient Egyptian light bulb, misinterpreted hieroglyphic, etc. Most OOPArts are either misidentified, hoaxes, or genuinely ancient but misunderstood. The Antikythera mechanism is fascinating, but doesn't require lost civilizations to explain. It's consistent with known Greek knowledge. Most other OOPArts are more mundane on close examination. The pattern here is clear. When we find genuine anomalies in the geological or archaeological record, we can usually explain them with natural or known historical causes. The temptation to invoke lost civilizations is strong because it's exciting, but it's rarely necessary. Part 7. The Fermi Paradox Connection. There's a reason this question matters beyond simple curiosity. It connects to the Fermi Paradox and the search for extraterrestrial intelligence. The Fermi Paradox asks, if intelligent life is common in the universe, where is everybody? Why haven't we detected alien civilization? One possible answer is that civilizations are inherently unstable. They arise, exist briefly, then destroy themselves or decline. The galaxy might be filled with ruin, with the remains of civilizations that rose and fell, leaving little trace. If this is true, then Earth might have experienced the same cycle multiple times. Perhaps civilizations arise, flourish for a few million years, then collapse. The planet recovers. Evolution continues. Millions of years pass. Another species evolves intelligent. The cycle repeats. This would explain why we don't see alien civilization. We're catching the universe in a between phase after ancient civilizations have fallen, but before new ones have arisen or reached interstellar capability. It would also suggest that our own civilization faces similar risks, that the great filter that prevents civilizations from becoming galaxy spanning might be ahead of us rather than behind us. The Silurian hypothesis paper was partly motivated by this question. If we're looking for traces of ancient civilizations on exoplanets, planets, orbiting other stars, what should we look for? If an alien civilization rose and fell on a planet a billion years ago, what traces might remain? What atmospheric signatures? What isotopic anomalies? What geological features would indicate past intelligence? If we struggle to imagine detecting an ancient civilization on our own planet, where we can access rocks directly, where we can drill cores and analyze chemistry in detail, how much harder would it be to detect one on an exoplanet, where we can only analyze atmospheric spectra from light years away? This perspective suggests we should be humble in our assumptions. Absence of evidence for alien civilizations, either currently active or anciently extinct, might simply reflect the difficulty of detection rather than their actual absence. Part 8. Non-human intelligence on Earth. Let's consider a different angle. What if intelligence arose on Earth multiple times, not in the deep past, but recently, in geological terms, and not in forms we easily recognize? Cetacean. Whales and dolphins are intelligent. They have large brains, complex communication, social structures, culture. Different whale populations have different songs that change over time, passed from generation to generation. They've existed for roughly 50 million years. Could they have developed civilization underwater? It seems unlikely. They don't have hands, can't manipulate objects precisely, can't use fire. These limitations probably prevent technological development, but they might have sophisticated cultures, philosophy, knowledge systems that we can't access because we don't speak their language. What if before humans, some ancient whale or dolphin species had developed even more sophisticated cognition? What if there were underwater civilizations, in some sense, complex societies with culture and knowledge, that we'd never detect because they built nothing permanent, left no artifacts? Cephalopods. Octopuses are remarkably intelligent, despite having evolved intelligence independently from vertebrates. They solve problems, use tools, show curiosity, and playfulness, but they're short-lived. Most species live only 1 to 2 years, and solitary, which prevents cultural accumulation. Each octopus must learn everything anew, but octopuses have only been around in their current form for tens of millions of years. Before them, there were other cephalopods, some quite large. Extinct nautiloids had shells up to 3 meters long. Could any ancient cephalopod species have evolved longer lifespans, social behavior, and intelligence sufficient for culture? Again, it seems unlikely, but we can't completely rule it out. If it happened, it left no trace. Dinosaurs redux. Let's return to dinosaurs, but with a different question. We've established that we have no evidence of dinosaur civilization. But what about dinosaur intelligence more generally? Some dinosaurs were clearly smart. Pack hunting raptors required coordination and communication. Large. Herbivores living in herds would have had social hierarchy. Troodon and similar theropods might have been comparable to modern corvids in intelligence. Is it possible that some dinosaurs developed complex behavior, maybe even simple cultures, tool use, teaching of skills, multi-generational knowledge, that wouldn't leave archaeological traces, but would constitute a kind of proto-civilization? Probably not to any significant degree, but it's a reminder that intelligence is a spectrum, not a binary. There might have been species throughout Earth's history that were more intelligent than we assume, that had richer inner lives, more complex society, but left no evidence we can read. Part 9. The Anthropocene and Future Geology. To understand what traces an ancient civilization might leave, let's examine what traces our own civilization will leave. We're currently in the Anthropocene, a proposed new geological epoch defined by human impact on the planet. What will this epoch look like to geologists millions of years from now? Plastic. We've produced billions of tons of plastic since the mid-20th century. Much of it will survive in the geological record as thin layers in sediment. Future geologists will find a sudden appearance of synthetic polymers in rock dating to the late 20th and early 21st century. This will be unusual, potentially diagnostic of a technological civilization, but plastics degrade eventually. Over millions of years, they'll break down through photooxidation, microbial action, and mechanical weathering. After 100 million years, it's unclear if recognizable traces would remain. Perhaps modified hydrocarbons in sediment, perhaps nothing at all. Concrete. We've produced vast amounts of concrete, more than any other manufactured material. Concrete is essentially artificial limestone, and it can survive in the geological record. But over millions of years, as it's buried, subjected to pressure and heat, it will be difficult to distinguish from natural limestone. Its presence wouldn't clearly indicate civilization unless we found it in obviously artificial structure, which would be unlikely to survive intact. Metals. We've mined and refined enormous amounts of metals, concentrating them in ways that don't occur naturally. Future geologists might find thin layers with elevated concentrations of aluminum, steel, copper, and rare earth elements, but these will be subtle, spread out, mixed with natural sediment. Radioisotopes. Nuclear weapons testing in the mid-20th century spread radioactive isotopes globally, particularly carbon-14, cesium-137, and plutonium isotopes. These will remain detectable for thousands to millions of years, depending on the isotope's half-life. This is perhaps the clearest signature of our civilization that will survive deep time. Carbon isotopes. Burning fossil fuels releases carbon dioxide with depleted carbon-13. This creates a distinctive isotopic signature in the atmosphere and, eventually, in sediment. And ice cores. This signature will remain detectable as long as these sediments survive, potentially for millions of years. Extinctions. We're causing a mass extinction event, the sixth in Earth's history. Species are going extinct at rates far above background levels, primarily due to habitat destruction, climate change, and direct hunting. This extinction event will be visible in the fossil record as a sudden decrease in biodiversity, a thinning of the fossil record across many lineages. Climate change. We're warming the planet by increasing greenhouse gases. This warming is rapid by geological standards and will leave signatures in sediment, changes in pollen distributions, showing species migrating toward poles, changes in ocean temperatures recorded in forum shells, changes in ice sheet extent visible in sediment cores. Taken together, these signatures create a distinctive package: elevated metals and synthetic materials, radioactive isotope, carbon isotope anomaly, rapid climate change, and mass extinction, all occurring simultaneously in the geological record. This package would be diagnostic of industrial civilization if found in ancient rock. But here's the key question. Would this package survive 100 million years? Some elements would. The carbon isotope anomaly, elevated metal concentration, the extinction event. Others might not. Plastics, radioactive isotopes, depending on half-life, concrete structure, and even the surviving signature might be subtle, requiring careful analysis to detect, easily attributed to natural causes if you weren't specifically looking for civilization. Part X, the search itself. If we take seriously the possibility of ancient civilization, how would we search for them? What would a research program look like? High-resolution geological survey. We'd need to examine sedimentary rock for from all periods with unprecedented detail, looking for anomalies, sudden changes in isotope ratio, elevated concentrations of metals or other elements, unusual mineral assemblages that don't match surrounding rock. This is already happening to some extent. Geologists study sediments in great detail for various reasons, understanding past climates, tracking extinction events, exploring for resources. If there were obvious anomalies indicating ancient civilization, we'd probably have found them by now. But subtle anomalies might remain undetected or be attributed to natural process. Careful excavation of unusual formation. Sometimes rocks contain structures that look artificial but are natural. Columnar basalt forming geometric patterns, iron formations creating banded patterns, concretions forming spherical shape. We'd need to carefully examine these to rule out artificial origin. This requires expertise to avoid false positives. Pareidolia, the tendency to see patterns where none exist, is strong. People see faces in rock, ruins in natural formation, artifacts in weathered stone, distinguishing genuinely. Unusual features from natural formations that merely look unusual requires careful scientific analysis. Analysis of mass extinction. If any mass extinctions were caused by civilizations rather than natural disasters, they might show distinctive patterns. Perhaps species going extinct in a different order than expected from natural causes. Perhaps evidence of selection. Some species surviving while related species went extinct, suggesting someone was choosing. This is speculative, but mass extinctions are already carefully studied. If there were anomalies suggesting non-natural causes, we'd likely have noticed. The fact that known mass extinctions match natural catastrophes doesn't prove there weren't others we've missed or misinterpreted, but it's not encouraging for the ancient civilization hypothesis. Deep ocean and subduction zone exploration. Much of Earth's surface has been recycled through subduction. Oceanic crust older than 200 million years barely exists. It's been subducted into the mantle. If civilizations existed in that time frame, evidence might still exist in deep ocean sediment or in the subduction zones themselves. Exploring these regions is technically challenging. The deep ocean is difficult to access. Subduction zones are geologically active, dangerous, and their rocks are heavily deformed. But it's not impossible. Deep sea drilling programs have retrieved cores going back millions of years. As technology improved, we might access older, deeper material. Unusual fossil assemblages. If civilizations existed, they might have left traces in fossil assemblages. Unusually clustered remains, suggesting cities or settlement. Modified bones or shells, suggesting tool use. Unusual species distribution, suggesting transport or domestication. Paleontologists already study fossil assemblages carefully. If there were obvious anomalies, we'd probably have noted. But subtler patterns might exist, overlooked because we're not looking for them, or present in rocks we haven't yet examined. Genetic archaeology. The genetic relationships among modern species tell us about evolutionary history. If an ancient civilization had domesticated or genetically modified organisms, this might show up as unusual patterns in the genetic record. Species with anomalously low genetic diversity, bottlenecks from domestication. Species with genetic similarities that don't match geographical distribution, suggesting transport. Or even anomalous genetic sequences that seem designed rather than evolved. This is highly speculative. Evolution is so creative, so varied in its solution, that distinguishing designed genes from naturally evolved ones might be impossible, especially after millions of years of subsequent evolution obscuring the original pattern. But it's theoretically a place to look. Mathematical patterns in ancient rock. If a civilization wanted to leave a message that would survive geological time, how would they do it? Perhaps they'd encode information in the structure of rocks themselves, creating patterns that are statistically unlikely to be natural. Some researchers have proposed looking for prime number sequences in crystal structures, for example, or for mathematical constants encoded in the ratios of layer thicknesses in sedimentary rock. This ventures into SETI territory, search for extraterrestrial intelligence, but applied to deep time rather than deep space. The problem is distinguishing signal from noise. Natural processes create patterns. Some appear mathematical. Fibonacci sequences appear in shells and plants. Hexagonal patterns appear in basalt columns. Fractals appear in river networks. Finding genuinely anomalous patterns that couldn't be natural would be extraordinarily difficult. Revisiting anomalies with new perspectives. Sometimes scientific paradigms shift, and things previously dismissed as impossible become recognized as real. Continental drift was ridiculed until plate tectonics proved it. Meteorites were considered superstition until chemistry proved they came from space. Bacterial fossils and ancient rocks were doubted until better microscopy confirmed them. Perhaps some already known geological anomaly, currently explained as natural phenomena, might look different if examined with the explicit question, could this be artificial? This requires careful scientific rigor to avoid falling into pseudoscience, but it's not inherently unreasonable. The challenge with all these approaches is distinguishing genuine anomalies from natural processes that merely look anomalous. Nature is incredibly creative. Geological processes can create patterns that seem designed, but aren't. Biology evolves solutions that seem engineered, but emerged through natural selection. The history of pseudoscience is littered with mystery that turned out to be misunderstood natural phenomena. But that doesn't mean we shouldn't look. Science progresses by asking questions, even uncomfortable ones, even ones that seem unlikely to have interesting answers. The Silurian hypothesis paper's real contribution wasn't proving ancient civilizations existed. It didn't, but rather showing that the question is scientifically tractable, that we can think rigorously about what evidence would survive, what we should look for, how we distinguish natural from artificial. Part EV, the probability argument. Let's think probabilistic. What are the chances that a non-human civilization existed on Earth before us? We need to consider several factors. Time available. Complex life has existed for about 600 million years. Vertebrates have existed for about 500 million years. Land vertebrates for about 370 million years. That's a lot of time for intelligence to potentially evolve. Number of lineages. Thousands, perhaps millions of species have existed during this time. Each represents an evolutionary experiment, a lineage that could potentially have evolved intelligence. Requirements for civilization. Intelligence alone isn't enough. You need manipulative appendages, hands, tentacles, something to make tools. Environmental access to resources, metals, fuel, materials, social behavior to accumulate and transmit culture. Longevity to learn and pass on knowledge. Energy surplus, freedom from constant survival struggle. Humans happen to have all of these, or develop them as intelligence evolved. But the specific combination is rare. Most intelligent animals lack one or more requirements. Dolphins are smart, but can't use fire. Octopuses are smart but short-lived and solitary. Elephants are smart and social, but lack fine manipulators. Selection pressure. Intelligence is metabolically expensive. The human brain uses about 20% of our energy, while being only 2% of body weight. Evolution only maintains such expensive traits if they provide significant advantage. For most of Earth's history, for most species, intelligence beyond a basic level hasn't been necessary for survival and reproduction. Humans evolved intelligence probably due to a specific set of circumstances. Social complexity requiring theory of mind, tool use, rewarding planning, and abstract thought. Environmental variability favoring flexibility over specialization. These circumstances might be rare. Extinction risk. Even if a species evolves intelligence and begins developing civilization, it faces extinction risks. Climate change, disease, predation, competition, resource depletion, accidents, bad luck. The longer a civilization exists, the more opportunities for something to go wrong. Detection probability. Even if ancient civilizations existed, we might not detect them. As we've discussed, evidence degrades over time. The older the civilization, the less likely we'd find traces. Putting this together, the probability of any given species evolving civilization is very low, but the number of species and the amount of time available are both very large. The product of these factors determines whether we'd expect ancient civilizations to have existed. Most scientific analyses suggest the probability remains quite low. Intelligence of the civilization building sort seems to require a very specific set of circumstances that happen for humans, but hasn't happened for any other species we know of in 500 plus million years of complex life. This suggests it's rare, not inevitable. Moreover, if it had happened multiple times, we'd expect to see evidence. The more times it happened, the more likely we'd have found something. The absence of clear evidence, while not conclusive, absence of evidence isn't evidence of absence, especially for things that might not preserve well, suggests it probably hasn't happened, or has happened so rarely and so long ago that all evidence is gone. But probably hasn't happened isn't the same as certainly hasn't happened. There's a non-zero probability, perhaps small, but not negligible, that we're not the first, that somewhere in Earth's deep past, hidden in destroyed rock, or waiting in sediments we haven't examined, there's evidence of another experiment in intelligence, another species that briefly achieved something like civilization before vanishing. Part twice. The implications. What would it mean if we discovered evidence of a pre-human civilization on Earth? The implications would be profound, unsettling, transformative. For our understanding of evolution, it would show that the evolution of intelligence and technology isn't a one-time fluke, but a possibility that can arise multiple times, given enough time and opportunities. This would have implications for our estimates of intelligent life in the universe. If it happened twice on Earth, it might be relatively common on other worlds, but it would also show that civilizations aren't necessarily stable or long-lasting. If a previous civilization rose and fell, leaving almost no trace, it suggests that the default outcome might be extinction rather than indefinite survival and expansion. This would be sobering for our own civilization's prospect, for our sense of human uniqueness. Much of human culture and philosophy rests on the assumption that we're special, that our intelligence and civilization represent something unprecedented, the pinnacle of evolution. The universe become aware of itself. Finding out we're not the first would be humbling. It wouldn't erase human achievement. We're still remarkable, still capable of art and science and love and meaning, but it would place us in a larger context, as one iteration of a process that has happened before and might happen again. For our place in time, we think of ourselves as the climax of Earth's story, the point toward which evolution has been building. Finding ancient civilizations would reveal this as hubris. We're not the climax, but a chapter, possibly a late chapter, but not necessarily the final one. Earth existed for billions of years before us. It might exist for billions of years after us. Other civilizations might have risen and fallen in the past. Others might rise in the future after we're gone. Our moment in the sun, however bright it seems to us, is a flicker in deep time for our environmental responsibility. If previous civilizations fell due to environmental collapse, depleting resource, changing climate, polluting their world, it would serve as warning. We're currently stressing Earth's system, changing climate, driving extinction, depleting resource, polluting air and water and soil. If we found that others did this before us, and it led to their fall, it would underscore the urgency of changing our behavior. Of course, we don't need ancient cautionary tales to recognize current problems. The physics of climate change, the biology of extinction, the chemistry of pollution, these are clear enough, but there's something visceral about seeing the ruins of a failed civilization, even if those ruins are just anomalous layers in ancient rock. For philosophy and meaning, many humans derive meaning from feeling that we're the universe's only intelligence, that consciousness and thought emerged here uniquely, that we're alone in a vast cosmos. Finding ancient civilizations would complicate this. We'd be one mind among others, our thoughts not unique, but echoing thoughts that occurred before. But it might also be comforting. We wouldn't be alone in history. Other minds, other perspectives, other experiments in consciousness would have existed. We'd be part of a larger story, connected across deep time to other beings who also looked at stars, wondered about their place in the universe, tried to understand and create and survive. Part 3, the question of contact. Here's where things get speculative, even fantastical, but worth considering. What if an ancient civilization didn't go extinct, but instead transcended, transformed, or left Earth? Transcendence. Perhaps they developed technology that allowed them to upload consciousness, to become digital entities, to exist in some post-physical form. They might still be here, invisible to us because they operate in computational spaces we can't perceive. Their presence as undetectable to us as our television signals are undetectable to ants. This is pure speculation, more philosophy than science, but it's a reminder that extinction might not be the only endpoint. A sufficiently advanced civilization might find ways to persist that don't involve biological bodies or physical artifacts. Underground, perhaps they still exist, but moved underground into deep caverns or ocean trenches, living in ways that don't interact with the surface world. We've explored very little of the deep Earth. The deepest mines go down only about 4 kilometers, barely scratching the surface of a planet with a radius of over 6,000 kilometers. Again, this seems unlikely. We'd expect to see evidence of their activity, heat from their energy use, vibrations from their industry, unusual chemical signatures in groundwater. We see none of this, but the deep Earth remains largely unexplored. Departure. Perhaps they left Earth, became spacefaring, and never returned. They might have spread across the solar system, then to other stars, leaving behind only the world where they originated. If they existed millions of years ago, all trace of their presence might have eroded away. Any space stations or moon bases would have been destroyed by meteor impact. Any any probes they sent to other star systems would be too far away and too small for us. This scenario has the advantage of explaining why we find no evidence. They cleaned up before they left, or time erased their traces. But it requires assuming they achieved space, which requires a level of technology we have no observation. Perhaps they're aware of us, watching from hiding, waiting to see what we do. This is the zoo hypothesis from SETI discussion. Advanced civilizations might let younger ones develop without interference, observing but not interacting. If an ancient Earth civilization still exists in some form and is watching us, they've been remarkably good at staying hidden. No verified contact, no undeniable artifacts, no clear evidence of their presence. Either they don't exist, or they're extraordinarily skilled at concealment. Integration. Perhaps they didn't go extinct or leave, but instead persisted in some reduced form. Their descendants still around, but unrecognized. Perhaps they devolved, lost technology, became simpler organisms that still exist, but show no signs of their civilized past. Evolution doesn't have a direction. Species can become more complex or simpler depending on environmental pressures. Perhaps the descendants of an ancient civilization are still here. Some species of deep-sea fish, perhaps, or cave-dwelling invertebrates, carrying in their genes the distant memory of intelligence long abandoned. This is highly speculative, bordering on unfalsifiable, which makes it poor science. But it's an interesting thought that we might share the planet with the descendants of Earth's previous mind, unknowing cousins separated by millions of years and vast evolutionary distance. All of these scenarios are extremely unlikely, unsupported by evidence, ventures into science fiction rather than science, but they illustrate the range of possibility, the many ways the story could have unfolded if ancient civilizations had existed. And they remind us that absence of evidence constrains but doesn't eliminate possibility, especially when dealing with deep time and the fragmentary nature of the geological record. Part 14. What we actually know. Let's ground ourselves back in established science. What do we actually know about intelligence and civilization on Earth? Intelligence has evolved multiple times independently. Vertebrate intelligence, in mammals, birds, evolved separately from invertebrate intelligence in cephalopods. This shows that intelligence isn't a one-off fluke, but a solution that evolution can arrive at through different paths. Tool use is relatively common. Many species use tools: primates, corvids, dolphins, sea otters, even some insects. This shows that the cognitive capacity for tool use isn't rare. Culture exists in non-human species. Whales have songs passed through generations. Chimps have different tool-using traditions in different populations. New Caledonian crows pass on specific tool-making technique. Culture, information transmitted socially rather than genetically, exists outside human. But cumulative culture is rare or absent in non-human. Human culture builds on it. We teach each generation what the previous generation knew, and they add to it. This ratcheting effect has allowed us to accumulate knowledge and technology far beyond what any individual could discover. Other species show simple culture, but not this cumulative quality. The specific combination of traits enabling civilization seems unique to human. Fine motor control, abstract language, long lifespan, social learning, environmental flexibility. We have all of these. Other species have some, but not all. Humans evolved civilization very recently. Anatomically modern humans appeared about 300,000 years ago. Agriculture began about 10,000 years ago. Writing about 5,000 years ago. Industrial civilization about 200 years ago. For most of our species' existence, we were hunter-gatherers without cities or complex technology. This suggests that even having all the prerequisites for civilization doesn't guarantee its rapid development. It took us 290,000 years to go from modern anatomy to agriculture. Why? What changed? Was it population size reaching a threshold? Climate stabilizing after the Ice Age? Random cultural innovations that sparked further innovation? The fossil record, while incomplete, is extensive. We have millions of fossils from hundreds of millions of years. We understand evolutionary relationships in great detail for many lineages. If other civilizations had existed, especially in the last 100 million years when preservation is better, we'd likely have found some evidence. Geological and geochemical records show no clear signs of ancient civilization, no unexplained isotope anomaly that match the package we'd expect from industrial civilization, no unusual metal concentrations that suggest mining and smelting, no extinction patterns that clearly indicate artificial causes. The anomalies we do find have good natural explanation. The more recent the past, the better the preservation. Fossils and geological features are more numerous and better preserved in younger rock. If ancient civilizations had existed in the relatively recent past, last 100 million years, we'd be increasingly likely to find evidence as we move forward in time. Yet we find nothing until human. No pre-human stone tool, no pre-human modified environment, no pre-human extinction with suspicious pattern. The archaeological and paleontological records start with human and only with human. Extraordinary claims require extraordinary evidence. This is Carl Sagan's dictum, and it applies here. The existence of ancient pre-human civilization is an extraordinary claim. It contradicts our current understanding of evolutionary history and paleontology. To accept it, we'd need extraordinary evidence, clear, unambiguous traces that couldn't be explained by natural processes. We don't have such evidence. We have gaps in the fossil record, unexplained geological features, mysteries about how some ancient human monuments were built. But none of these require ancient civilizations to explain. They're simply areas where our knowledge is incomplete, which is normal in science. The responsible scientific position is therefore, based on current evidence, no pre-human civilizations existed on Earth, or if they did, they existed so long ago and left so little trace that detecting them may be impossible. This doesn't mean we stop looking or asking questions, but it means we need compelling evidence before revising our understanding. Part 15, the Fermi Paradox. Revisited. Let's return to the question of why this matters. The possibility of ancient Earth civilizations connects to one of the deepest questions we can ask. Are we alone in the universe? The Fermi Paradox, named after physicist Enrico Fermi, observes that the universe is vast and ancient. There are hundreds of billions of stars in our galaxy, perhaps trillions of planets. If life and intelligence are common, the galaxy should be filled with civilizations, some far older than us. Yet we see no clear evidence of them. No radio signals, no megastructures, no signs of galaxy-wide engineering. Where is everybody? Many solutions have been proposed. The Great Filter. Something prevents most civilizations from reaching interstellar travel capability. This filter could be behind us. Life is rare. Intelligence is rare. We're lucky to have made it this far. Or ahead of us, civilizations inevitably destroy themselves or stagnate before becoming interstellar. If ancient civilizations existed on Earth and went extinct, it suggests the filter is ahead of us. Intelligence might be common, but long-term survival might be rare. This would be bad news for our prospect. The zoo hypothesis. Advanced civilizations leave younger ones alone, observing without interfering. We're in a cosmic zoo or nature preserve. This seems anthropocentric and hard to verify, but it's not impossible. They're here but hidden. Civilizations are around us, but using technology or methods we can't detect. This could apply to ancient Earth civilizations too. Perhaps they're still here in some form we don't recognize. Space is too big. Even if civilizations exist, the distances are so vast that contact is improbable. Signals attenuate. Travel takes too long. Each civilization exists in isolation, surrounded by light years of emptiness. We're early. Perhaps we're among the first civilizations in the galaxy. Star formation peaked billions of years ago, but planets needed time to form. Life needed time to evolve. Maybe we're in the first wave of intelligence in the universe. Intelligence is rare. Perhaps the evolution of civilization-building intelligence requires such specific circumstances that it happens only once per galaxy or less. We might be alone, or nearly so. Each of these solutions has implications for the question of ancient Earth civilization. If intelligence is rare, explaining why aliens are scarce, then finding that it evolved twice on Earth would be surprising, though not impossible if Earth's circumstances are special. If civilizations inevitably self-destruct, explaining why we see no ancient alien, then finding ancient Earth civilizations that went extinct would support this dark conclusion. If civilizations transcend or hide, explaining alien absence, then ancient Earth civilizations might still be around in forms we don't recognize. The question, are we alone in the universe? And the question, are we the first on Earth? Are connected. Both probe the rarity or commonness of intelligence, the stability or fragility of civilizations, the likelihood of detection versus the likelihood of existence. Part 15. The philosophical weight. Beyond the science, beyond the evidence, or lack thereof, there's something philosophically profound about this question. It forces us to confront our assumptions about humanity's place in the universe. We're used to thinking of ourselves as special. The religious traditions of many cultures place humans at the center of creation, made in God's image. the purpose for which the universe exists. Even secular humanism retains echoes of this, where the universe become aware of itself, consciousness emerging from matter, meaning arising from meaninglessness. Finding ancient civilizations would challenge this narrative. We wouldn't be the first minds to contemplate existence. Other species, other forms of consciousness would have asked the same question, wondered about their origin, searched for meaning before us. But would that diminish us, or would it enrich our understanding? Consider, if other civilizations existed and vanished, they left the world for us. They didn't permanently damage the planet. Life recovered from whatever they did. Evolution continued, and eventually we arose, had our chance, created our own civilization. In a sense, we'd be connected across time to those ancient others. We'd be fellow travelers on a journey toward understanding, separated by millions of years, but united in the experience of consciousness, in the quest for knowledge, in the building of cultures and technologies. Their existence wouldn't erase our achievements. Art and music and literature and science, these would still be valuable, still be beautiful, still be meaningful. They'd just be situated in a larger context, one episode in a longer story. And perhaps there's comfort in that. If others came before us, if they too struggled and built and wondered and eventually passed away, then we're not alone in history. We're part of a pattern, a rhythm of arising and falling that might be fundamental to how intelligence works in the universe. This could be depressing, suggesting our civilization too will fall and be forgotten. Or it could be inspiring, suggesting that even if we fall, others will come after us, that the story continues, that consciousness and civilization are resilient enough to emerge again and again. Part 17, the future perspective. Let's shift our view and look forward. Suppose our civilization ends tomorrow, not through extinction, but through some transformation we can't foresee. What would remain for geologists 100 million years in the future? We've already discussed some of this: plastic layers, carbon isotope anomalies, elevated metals, radioactive isotopes. But let's think more carefully about specific structures and whether they'd survive. Cities, modern cities, are built of steel, concrete, glass, materials that seem permanent but aren't on geological timescales. Steel rusts. Concrete weathers. Glass breaks down. Within thousands of years, unattended buildings collapse. Within millions of years, even their foundations would be worn away by erosion or buried under sediment. Some exceptions. Structures in very dry environments or rapidly buried by sediment might be preserved longer. Structures that happen to be in locations that become buried rapidly by geological processes could fossilize, though they'd be deformed, compressed, and difficult to recognize. Infrastructure, roads, bridges, dams, tunnels, these would erode relatively quickly. Tunnels might last longest if they're in stable rock, but they'd fill with sediment, collapse, and eventually be compressed into layers indistinguishable from natural strata. Deep mines might survive longer than surface structure. They're already underground, protected from surface weathering. But over millions of years, they'd fill with groundwater. Mineral deposits would grow in them. Tectonic activity would deform them. A 100-million-year-old mine shaft would be extraordinarily difficult to distinguish from a natural cave or fissure. Landfills. Our garbage dumps contain vast amounts of material in concentrated areas. Plastics, metals, glass, organic waste, all compressed and buried. These would create unusual sedimentary layers, but over time, the materials would break down, compact, and alter. After millions of years, a landfill might appear as an unusual layer in rock with elevated concentrations of certain elements, but not obviously artificial. Nuclear waste. We've created materials that will remain radioactive for tens of thousands to millions of years. Plutonium-239 has a half-life of 24,000 years. It'll remain detectable for hundreds of thousands of years. Other isotopes last even longer. This is perhaps our most enduring legacy, the radioactive signature of our nuclear age. Artificial satellite. We've launched thousands of satellites. Most in low orbit will eventually decay and burn up in the atmosphere. But satellites in high orbit, particularly in geostationary orbit 36,000 kilometers up, will remain for millions of years, slowly being perturbed by gravitational effects, but persisting as a ring of artificial debris around Earth. If a future civilization arose and looked carefully, they might find this ring of ancient satellites corroded and damaged, but recognizable as artificial. This would be clear evidence of our existence. But if they arose after those satellites had fallen, which they eventually will, given enough time, this evidence would be lost. Geological marker. The clearest evidence would be the geochemical signatures we discussed. Carbon isotopes, elevated metals, extinction patterns, climate change signals. These would persist in sedimentary rock for as long as those rocks survive, potentially hundreds of millions of years if the rocks aren't subducted, melted, or eroded away. A future intelligent species studying geology would find a thin layer in rocks dating to the late 20th and early 21st centuries, assuming they could date rocks precisely, which would require their own sophisticated science. This layer would show unusual chemistry, rapid climate change, and mass extinction. They'd recognize it as anomalous and might infer a civilization caused it. But would they be certain? Or would they propose natural explanations, massive volcanism, an undetected asteroid impact, some geological process we don't yet understand? Without finding artifacts, without clear evidence of technology, could they prove a civilization existed? This is the mirror of our question. Just as we might not recognize ancient civilizations in our past, future civilizations might struggle to recognize us in their deep past. Part 17. Living with uncertainty. We've explored this question from many angles: scientific, philosophical, practical, and we've arrived at a conclusion that's both clear and unsatisfying. We don't know for certain whether we're the first civilization on Earth, but all available evidence suggests we probably are, or at least we're the first in the last several hundred million years, during which preservation is good enough that we'd likely find traces. This uncertainty is uncomfortable. Humans like definitive answers. We prefer knowing to not knowing, certainty to probability, but much of science, especially science dealing with deep time and rare events, operates in the realm of probability and uncertainty. We can't prove no ancient civilizations exist. We can only say that if they did exist, they left no traces we've found, or left traces so subtle we've misinterpreted them as natural. This doesn't mean they didn't exist, but it means believing they existed requires accepting a claim without clear supporting evidence, which goes against scientific methodology. The responsible position is agnostic, with a strong lean towards skepticism. Probably no ancient civilizations existed, but we remain open to evidence if it appears. This is how science should work: skeptical, but not closed-minded, demanding evidence, but willing to revise beliefs when evidence warrants. Living with this uncertainty means accepting that Earth's deep past holds mysteries we may never solve. Rocks from billions of years ago have been destroyed or transformed beyond recognition. Even relatively recent rocks from tens of millions of years ago are incomplete, fragmentary, subject to interpretation. We can reconstruct much of Earth's history: the formation of the planet, the origin of life, the evolution of complex organisms, mass extinctions, climate changes, continental drift. Our understanding is detailed and grows more accurate with each year of research, but there are limits. There are questions we can't answer with certainty. And were there ancient civilizations before humans? Might be one of those. Questions, not because the answer is yes, but because even if the answer is no, proving it conclusively is difficult. You can't prove a negative, especially when dealing with evidence that degrades over time. This doesn't mean the question is pointless. Exploring it has value. It teaches humility. We don't know everything, and some things we might never know. It refines our thinking about what evidence survives, what we should look for, how to interpret ambiguous data. It connects to larger questions about intelligence in the universe, the stability of civilizations, our own long-term prospect. It reminds us that Earth has a deep history, that the present is just one moment in a vast story, that much has happened before us, and much will happen after us. Part 19, the message to ourselves. If we take this question seriously, if we contemplate the possibility that civilizations have risen and fallen before us, what does it say about our own civilization? It says we're fragile, that intelligence and technology don't guarantee survival, that civilizations can end, leaving little trace, forgotten by the future. This is sobering, but important to recognize. It says the planet is resilient, that even if civilizations collapse, life continues, evolution proceeds, and the Earth endures. This is comforting in a cosmic sense, though cold comfort if you're living through a collapse. It says our legacy is uncertain. We want to be remembered, want our achievements to endure, want future beings to know we existed. But deep time is relentless. Eventually, almost everything is erased. We should build and create and strive not for immortality, which is probably impossible, but for the inherent value of building and creating and striving. It says we should focus on the present. We exist now. We have this moment, this opportunity, this chance to make meaning, to reduce suffering, to increase knowledge, to create beauty. Whether civilizations existed before us or will exist after us is interesting, but not directly relevant to how we should live. It says we're connected to the universe. Whether we're the only intelligence Earth has produced or one among many, we're part of a cosmos that seems capable of generating consciousness that contains the possibility of understanding itself through minds like ours. That's remarkable regardless of how common or rare it might be. If ancient civilizations did exist, they failed to become permanent, failed to spread across the galaxy, failed to leave messages we could unambiguously find. Either they didn't exist or they faced challenges they couldn't overcome. We face similar challenges: climate change, resource depletion, weapons of mass destruction, artificial intelligence risks, pandemic risks, the general fragility of complex systems. Our response to these challenges will determine whether we persist, whether we spread beyond Earth, whether we leave traces that would survive deep time. We can't control everything. Asteroid impact and supervolcanoes are beyond our current capability to prevent, but we can control how we treat our planet, how we manage our technology, how we organize our society. The question, "Are we the first?" might ultimately matter less than the question, "Will we be the last?" Will we be the civilization that finally persists, that spreads beyond one world, that survives long enough to become clearly detectable in the deep geological future? Or will we be another brief experiment, another iteration in the universe's exploration of what intelligence can do? Part Text X, the wonder of the question. As we come to the end of this exploration, as the questions settle like sediment in still water, let's acknowledge something important. This question is wonderful precisely because we can't definitively answer it. Science progresses by answering questions, but it also progresses by asking better questions, by probing the boundaries of what we can know, by confronting uncertainty. The question of ancient civilizations sits at that boundary. It's not pseudoscience. It's based on legitimate scientific thinking about preservation, deep time, and the detectability of technological signature. But it's also not mainstream science, because we lack evidence to make it a productive area of research. It exists in that liminal space between legitimate inquiry and speculation. And that's okay. That's good even. We need questions like this to remind us of how much we don't know, how mysterious the universe remains despite our progress, how deep time and the vastness of possibility stretch beyond our current understanding. When you look at ancient rock, at fossils hundreds of millions of years old, at the record of deep time written in stone, you're seeing fragments of a vast story, most of which is lost. The fossil record captures perhaps 1% of species that ever lived. The geological record is even more fragmentary. Most rocks that ever formed have been destroyed. We're looking at the universe through a keyhole, seeing a tiny fraction of what exists and has existed, trying to reconstruct the whole from fragments and hints and indirect evidence. That we can do this at all, that we can look at ancient rock and infer oceans and mountains and climates that existed hundreds of millions of years ago is extraordinary. But we should be humble about what we can't see through that keyhole. There might be things we're missing, patterns we haven't recognized, evidence we've misinterpreted. Probably not ancient civilization. The weight of evidence suggests they didn't exist. But maybe other surprises, other revelations waiting in rocks we haven't examined or haven't examined correctly. The joy of science is that it's never finished. Every answer generates new questions. Every solved mystery reveals deeper mystery. We'll never know everything, never achieve complete understanding. There will always be a frontier, always be edges where the known meets the unknown. Are we the first? Civilization on Earth sits at that edge. And whether the answer is yes or no, whether we ever find definitive evidence one way or the other, the question itself is valuable. It makes us think about deep time, about the fragility of civilization, about what leaves traces and what vanishes, about humanity's place in the vast story of this ancient planet. Closing, our place in deep time. So where does this leave us? Standing on a planet 4.5 billion years old, members of a species 300,000 years old, participants in a civilization perhaps 10,000 years old, asking whether anyone was here before us, whether anyone asked these same questions, wondered about their place in time, tried to understand the universe that gave birth to them. The answer, based on current evidence, is probably not. We're probably the first to ask these questions, the first to build cities, the first to develop science and art and philosophy. This makes us not just rare, but potentially unique in Earth's history. The first time this planet has produced minds capable of understanding their own origin. That's a profound responsibility. We're the first to know what Earth is, what the universe, how evolution works, how deep time stretches. We're the first to recognize that we could destroy ourselves, that our actions have consequences, not just for us, but for all life on this planet. And we might be the first to recognize that our time is temporary, that we exist in a brief window between the deep past and the deep future, that whatever we build will eventually erode, that our monuments will crumble, that our civilization will someday be nothing but a thin layer of unusual chemistry in ancient rock. But that impermanence doesn't make our existence meaningless. It makes it precious. We have this moment, this chance, this opportunity to exist, to think, to feel, to create, to love, to understand. Whether others came before us or will come after us, this moment is ours. So sleep well, child of the present, inhabitant of this brief, now between the vast past and the unknowable future. Dream of ancient possibility and future wonders, of intelligence arising again and again in the universe's patient exploration of what consciousness can do, of civilizations rising and falling like waves on the shore of deep time. And know that you're part of this story, this long experiment in complexity and awareness, this universe trying to understand itself. From all of us at Earth's history, thank you for joining this journey into uncertainty, into the spaces between what we know and what we can imagine, into the vertiginous depth of geological time where certainty gives way to wonder. If this helped you see human civilization as both precious and fragile, as both unique and contingent, as both significant and temporary, then we've served our purpose. Until next time, rest well. The rocks remember more than we know. The future remains unwritten, and the question, that beautiful, unanswerable question, continues echoing through time. Good night.